you know the exact feeling. The message comes through, and you read it once, then read it again. As if the second reading might produce a different result. It does not. Your chest tightens. Something drops in your stomach, a specific sinking sensation that has no physical cause you can identify. Your throat closes slightly. Your hands might be cold. None of this makes sense if rejection is just an emotion. Emotions happen in your mind. They do not tighten your chest or sink your stomach or make your hands go cold. Bodies do not respond to information the way yours just did, unless that information registers as something more than a thought. And here is what the neuroscience says about what just happened inside your skull. Your brain did not process that rejection as an emotional event. It processed it as damage. The same neural machinery that fires when you burn your hand, when you break a bone, when something physically tears inside your body, fired in response to a message on a screen. Your brain cannot tell the difference between rejection and physical pain, not metaphorically. At the level of which neurons activate and which brain regions light up on a scanner, they are the same event. This is not a new idea dressed up in scientific language. It is a finding with a specific origin, a specific researcher, and a specific moment when the data came back and changed what we thought we knew about how social pain works. In 2003, a neuroscientist named Naomi Eisenberger at UCLA was running a study using fMRI brain imaging to track what happens in the brain during social exclusion. The experiment was a computer game called Cyberball. Participants played a simple ball-tossing game with what they believed were two other players elsewhere in the building. For the first few minutes, the ball was passed normally. Then the other two players stopped including the participant entirely. They passed the ball back and forth between themselves while the participant watched. That was the whole manipulation, no insult, no confrontation, no meaningful social consequence of any kind, just being left out of a ball game by strangers on a screen. What Eisenberger found in the brain imaging data was not what she expected. The anterior cingulate cortex, the region that processes the emotional component of physical pain, activated during social exclusion with the same profile it shows during actual physical injury. The more distressed participants reported feeling about being excluded, the more strongly this region activated. The brain was treating a social slight as a wound, and it was using the same tissue to process both. But Eisenberger's study was only the beginning, because cyberball is a mild, abstract, consequence-free exclusion. It tells you what happens in the brain when a stranger stops passing you a virtual ball. It does not tell you what happens when someone you loved looks at you and decides they are done. That question was answered in 2011 by a team of researchers at the University of Michigan led by Ethan Cross. They recruited participants who had gone through an unwanted romantic breakup within the past 6 months. People who reported that thinking about the rejection still produced significant emotional distress. They put these participants in an fMRI scanner and showed them two things. First, a photograph of their ex-partner paired with instructions to think about the moment the rejection occurred. Second, a physical pain stimulus, a thermal device held against the forearm that produced a sensation described as intense but not damaging. When the researchers compared the brain activation patterns from both conditions, the results collapsed the remaining distance between social pain and physical pain entirely. The same regions, the secondary somatosensory cortex, the dorsal posterior insula, areas previously understood to process the sensory physical experience of bodily pain, not the emotional response to it, but the raw physical sensation itself, activated during the rejection condition with the same intensity as during actual physical heat pain. Thinking about being rejected by someone you loved produced brain activity, indistinguishable from the activity produced by a device burning your arm. Cross's conclusion was direct. Rejection does not just feel like physical pain. For the brain processing it, rejection is physical pain. The distinction the English language draws between emotional and physical hurt does not exist in the neural architecture that processes both of them. This raises the question that the imaging data cannot answer on its own. Why? Why would a brain that needed to solve the problem of physical survival build its social pain system on top of its physical pain system? Why not separate them? Why route the experience of being left out through the same circuitry that handles broken bones and burns? The answer is evolutionary, and once you see it, it is difficult to unsee. For the vast majority of human evolutionary history, social rejection was not a psychological inconvenience. It was a survival emergency. A human being expelled from their group on the African savanna 100,000 years ago was not going to have a difficult week. They were going to die from predators, from exposure, from the inability to access food and water that required cooperative effort to obtain. The group was not a social preference. It was the life support system. Exclusion from it was functionally identical to a serious physical injury in terms of what it did to your survival probability. A brain that treated social rejection as trivial, that did not generate an urgent, motivating, impossible-to-ignore response to the threat of exclusion, was a brain attached to a body that was about to be removed from the gene pool. The pain is not a bug. It is the alarm system, built to be loud enough that you could not ignore it, built to be painful enough that avoiding it would motivate every behavior necessary to stay connected to the people who kept you alive. The anterior cingulate cortex does not distinguish between a broken bone and a broken relationship because for most of human history, both of them carried roughly the same probability of killing you. Here is where it becomes something harder to sit with. If rejection, pain runs through the same neural pathways as physical pain, and if those pathways respond to the same interventions, then something uncomfortable follows. In 2010, psychologist C. Nathan DeWall at the University of Kentucky ran a study that tested exactly this. Participants took either acetaminophen, standard over-the-counter pain medication, or a placebo for 3 weeks. Every day, they reported their levels of social pain, the everyday experience of feeling hurt, rejected, or excluded in their normal lives. The participants taking the pain medication reported significantly lower levels of hurt feelings than those taking the placebo. Tylenol reduced social pain not because the feelings were imaginary, because they were running through pain pathways that the medication was dampening. The same mechanism that reduces the throb of a headache was reducing the sting of everyday rejection. This finding is genuinely disturbing if you follow it to its logical end, because it means the distinction most people draw between real pain and emotional pain, the distinction that leads people to tell others to toughen up, to stop being so sensitive, to treat social hurt as something fundamentally less legitimate than physical hurt. That distinction does not exist in the brain being told to feel it. The person who cannot get out of bed after a breakup is not weaker than the person who cannot get out of bed after a surgery. They are operating in the same system. The system is doing the same thing. The only difference is that one of them is visible on an X-ray and the other is not. There is one more layer, because the research does not stop at showing that rejection hurts the same way physical pain hurts. It shows something about memory that makes the whole picture stranger. In the same Michigan study, Cross found that the brain regions activated by rejection were not just the pain processing regions. They included areas associated with the re-experiencing of physical sensation, regions that in other contexts are associated with the physical reliving of past pain. This means that when you replay a rejection in your mind, when you lie awake reconstructing the conversation, the moment, the exact words, your brain is not just thinking about a painful event. It is re-experiencing a physical sensation. The replay is not a memory of pain. It is pain. Every time the loop runs, the anterior cingulate cortex and the posterior insula fire again. Every time you revisit the rejection, you are physically re-injuring yourself in the only way the brain distinguishes as real. The rumination that follows rejection is not a choice or a character flaw. It is a pain system that does not yet know the threat has passed, running its standard protocol for a wound that has not healed, checking it again and again the way you cannot stop pressing a bruise. The chest tightness you felt when that message came through was real. The sinking sensation was real. The physical response your body produced to information on a screen was produced by the same system that produces your body's response to fire. You were not being dramatic. You were not being weak. You were running an alarm system that has kept human beings connected to each other for hundreds of thousands of years by making disconnection impossible to ignore. The system does not know that the threat it was built for no longer looks like exile on a savanna. It only knows that something that matters to your survival just registered as lost. And it responded the only way it knows how, with pain. actual, measurable, neurologically identical pain. The kind that shows up on a scan, the kind that responds to medication, the kind that was never, at any point in its long history of keeping humans alive and connected, ever just in your head.